In this video, we're gonna solve another problem, which is asking us to find the equivalent circuit of Thevenin. So let's crack on and do this. So as always, let's draw our circuit. So in this case, our circuit is gonna be by this generator here. Then we're gonna have a resistance. And then we're gonna have, this is a node, another resistance, another node, and another resistance, and a node. We're gonna have this one open. I'm gonna call this point A. And then down here, I have everything like the same as above. And here in between a resistance. Then here in between resistance first, and current generator, which points in this direction. And then over here, well, just a resistance. There we go. And there we go. This is another node, and this one is my point B. So I'm gonna call my voltage generator E. This is gonna be my R1, resistance 1, R2, this is gonna be R1 as well, gonna be R1 as well, this R3, R4, and J, our generator of current. Okay, so in this case, the problem is saying for the circuit below, we know E equal to 12 volts, Ri equal I ohm, which basically means that R1 is 1 ohm, R2 is 2 ohms, R1 is 1 ohm, R1 is 1 ohm, R3 is 3 ohm, R4 is 4 ohm, and so on and so forth. And J equal to 2 amperes. Find the Thevenin equivalent circuit at A, B. Okay, so basically what it's asking us is to find the and draw the Thevenin equivalent circuit and these 2 points A, B. In order to do that, we're going to do the following. First of all, let's make all these passive. Okay, so by making it passive, I basically mean that the current generator is going to be turned into an open circuit. So those two are not gonna, there's not going to be anything here. And the voltage generator instead is going to be turned into a short circuit. So this is just going to be, you know, a straight line. So I'm just gonna comment this. Let's make this passive first. Okay, so by making it passive, as I said, I'm basically gonna have nothing here where there used to be the voltage generator, just you know, just a straight line, which basically means a short circuit. Then a resistance. Then here I'm gonna have the same resistance. Here I'm gonna have the resistance. And again the resistance, but not here. There isn't gonna be anything. Just gonna be an open circuit, as this generator of current is gonna be made passive. Then here we're gonna have a resistance. And here we're gonna have our point A, just like before. Down here, it's gonna be one node, another node. Over here, I'm just gonna have nothing. So it's an open circuit. And up here, I'm gonna have the same resistance as before. And then this one is going to be my point B, just like before. So this is R4, this is R3, this is R1, this is R1, this is R2, and this is R1 as well. Okay, so now the idea is to find the RTH, so basically the resistance of the Thevenin circuit. So RTH, R Thevenin, is going to be given by the resistance of the Thevenin equivalent circuit. It's going to be given by, sorry. Well, it's going to be given by R1 in parallel with R2 plus R1 plus R3, everything in parallel with R4. So this is actually going to be given by R1, as I said, in parallel with R2, okay, plus R1 plus R3, everything in parallel with R4 here. So if we plug numbers into this, we get that R Thevenin, RTH, is basically going to be given by, well, 1, that is 1 ohm, in parallel with 2, plus 1, plus 2, everything in parallel with 4. So RTH is, well, let's do this. 1 parallel with 2 basically means 1 times 2 over 1 plus 2. Then we have, well, plus 1 plus 2 is plus 3. And then everything in parallel with 4. So RTH is actually 2 times 1 is 2. And 2 plus 1 is 3. So 2/3 plus 3. Everything in parallel with 4. So RTH is actually going to be given by, well, we have a 3, we have a 2, we have a 9, parallel with 4. And then we have our RTH, which is basically 11 over 3 in parallel with 4. So this is going to be well, let's just modify. Well, yeah, I wanted to keep the fraction, but it's not possible. I mean, it can be possible, but I don't. For circuit in basically better not to keep the fraction. So I'm just gonna say that 11 divided by 3 is gonna be 3.66. So 3.66 times 4 over 3.66 plus 4. And then I'm lazy, so I'm just gonna use my calculator here. So this 1 times 4 is 14.66 over plus 4, which is 7.66. So basically our TH is going to be 14.66 over 7.66. So roughly 1.91. Yeah, roughly 1.91 ohm. Okay, so now that we have found our TH, which is the Thevenin resistance, we're going to crack on, and we're basically going to say, okay, I'm going to use the superposition of fx now, which is basically gonna let me consider those two generators individually. So the generator of current and the generator of voltage individually, and then I'm gonna use, as I said, the superposition of effects. So I'm gonna sum the effects and get the total result, the total effect of those two combined. So let's just do this. Indeed, I'm just gonna consider as starting point only the generator E. So this one is gonna become an open circuit where there is J. I'm just gonna consider E. So if I just consider E, I'm going to have this is still going to be my generator and the resistance, and over here I'm still going to have my resistance R2. Here I'm still going to have this, and I'm still going to have this, but here I'm going to have an open circuit because there is no J anymore. Here I'm going to have R3, and down here I'm gonna have R4, and then A and B. Those 2 points to have just like before. So this one is here. This one is an open circuit once again, and this one is right here as well. So plus A minus. This one is R1. I'm gonna use red for the I to say that this is I, this is the current. Well, I'm just gonna say I total. I'm just gonna call it I total. These are R2, R1, R1, R3, R4, and I'm gonna consider this I first R4. Okay, so basically the idea here now is that I'm basically gonna say, okay, from here to here, gonna be plus minus. I'm gonna have a difference of potential, which is gonna call VAB, And what I want to find really, before finding VAB, well, VAB first actually, because I'm going to have the two effects just like before in the former video. So I'm going to have VAB first and VAB second. Before doing that, I'm gonna and finding I total. I'm gonna say that, well, basically I total as I defined it is gonna be E, so my generator, over R equivalent. But I gotta find R equivalent. This is just, you know, this is just Ohm's law, so it's pretty straightforward. But I gotta find R equivalent. So R equivalent is actually going to be defined as such. It's going to be defined by having R1 plus R3, basically R1 plus R3 plus R4. Everything in parallel with R2. So I will basically have R1 plus R3 plus R4, everything in parallel with R2 plus R1. So if we plug numbers into this, we're going to have our AQ, which is going to be equal to R1, which is 1 ohm, plus R3, which is 3 ohms, plus R4, which is 4 ohms. Everything in parallel with R2, which is 2 ohms. Whoops, I made a boo-boo. Yeah, there we go. And then everything plus R1, which is 1 ohm. So this is going to give us our EQ equal to, well, 4 plus 3 plus 1 is 8. So I'm going to have 8. I don't need the parentheses anymore. So 8 in parallel with 2 plus 1. So our EQ is equal to 8 times 2 over 8 plus 2 plus 1. So our equivalent is 16 over 10 plus 1. So basically our EQ is going to be equal to 10, 16, 10. So basically our EQ is 26 over 10, which we can also just, you know, rewrite, since we wrote everything and as not as fractions, as 2.6. So REQ, I'm gonna write it here, is 2.6 ohm. So let me just turn the page. Now we have everything we need to find I total, which I defined as before as E over REQ, which we have just found because of the Ohm's law. So I total, it's just E, which was it 12 volts? Yeah, it was 12 volts. So is actually going to be 12 volts over REQ, which we just found was 2.6 ohm. So I total is 4.61 ampere. Now we're gonna find the reason why I wrote this is that the idea is that I want to find I first R4. And by finding I first R4, we know that I first R4 is actually going to be a subset of the I total. So, and we have a resistance here. So what will it be? Well, it is going to be pretty simple because I first R4 is actually going to be I total times, and we will basically have R2, okay, R2 over R2 plus R1 plus R3 plus R4. So, as I said, this is going to be R2 over R2 plus R1 plus R3 plus R4. And again, if we plug numbers into this, we'll get that I total, which we have just found is 4.61 amperes. Then we have all those bunch of resistances. I'm sorry. I'm really sorry. So R2 was 2 ohms. R2 is 2 ohms plus 1 ohms plus R3 is 3 ohms plus 4 is 4 ohms. R4, I first R4 is therefore 4.61 times 2 over, well, sorry, well, 4 plus 3 plus 2 plus 1. So it's basically 10 as they add up to 10. Now I can just say, okay, let me just get rid of this 1 over 5. And I can say, okay, so I first R4 is actually 4.61 over 5. And if I grab my calculator once again, I can find that it's actually gonna be 4.61 over 5, 0.92 amperes. 0.92 amperes. There we go. So now I have everything I need to find V first AB, which is just going to be given by R4, so the resistance I had there, times I first R4, which I have just found. So V first AB is going to be given by R4, which was 4 ohms, times this guy here, so 0.92 amperes. So V first AB is going to be 3.68 volts. So we're getting there. Now we have to do the other half. As I said, we just analyzed the we just considered the voltage generator, and we turned the current generator into an open circuit. Now we're gonna do the opposite. We're gonna consider the current generator, and we're gonna turn the voltage generator into a short circuit, like so. So let's just do this, because in this way we're gonna find VAB not first but second, and then we're gonna add those two effects together and find our solution. So let's just do this. Now, if we consider only the generator of current, as I said, the generator of voltage is gonna become a short circuit. So there's not gonna be anything here, just a straight line. Then we're gonna have the resistance just like before. Then we had the resistance here. Here we had another resistance. There was another resistance here. Here there was the generator of current called J. Then we had another resistance here, and then we had another resistance here, and then this one was point A, and down here we had our point B. And as always, this was R1, this was R2, this was R1, this was R1, this was R3, this was R4, and that was basically it. But this time, difference of potential VAB is going to be VAB second, because we are considering now the second circuit, which we're then gonna add thanks to the superposition of effects. And I'm gonna consider this current here, which we called I first R4. Now it's gonna be I second R4. Okay, so again, I'm gonna have I'm gonna say that we're basically gonna have two R left and R right. And I'm gonna call them R left, which is gonna be given by R1 in parallel with R2 plus R1. Okay. So R1 in parallel with R2 plus R1. So if we plug number into this, we have that R left is R1, which is 1 ohm, parallel with R2, which is 2 ohms, plus R1, which is 1 ohm. So R left is 1 times 2 over 1 plus 2, everything plus 1. Therefore, R left is 2 over 3 plus 1. So R left is just 3, 2, 3. R left is 5 over 3, which we can also write as, well, you know, basically 5 over 3, just 1.66 ohm. So, and then now I'm gonna find R right. Is it clear what I'm doing? Like R1 parallel with R2 plus R1. And now R right, so on the right hand side, I will basically have R3 plus R4. Okay, so those two only. So now I'm gonna have, as I said, R3 plus R4. So again, so if I plug number into this, right, I have 3 ohms plus 4 ohms, which is gonna give me 7 ohms. So now I have everything I need to calculate and find I second R4. So this guy here, which is gonna be given by J, which is my generator of current, times R left over R left plus R right. So I second R4 is actually J, which was, I don't remember, okay, 2 amperes. Yeah, the problem was giving us J, so it's 2 amperes times R left, which we have just found, so was 1.66 ohms, over R left, so again 1.66, plus R right, which was 7 ohms. So I second R4 is going to be given by 2 times 1.66 over 7.66. Oh, well, no. What am I doing? 8 point, yeah, 7 plus 1.66. So I second R 4, and this is a 4. Is it going to be given by, well, 2 times 1.66 is 3.32 over 8.66. So if we divide them, I get second R4 equal to roughly 0.38 amps. So now I have everything I need to find V second AB. So V second AB is going to be given by R4, the resistance here, times the current here, so this current here, I second R4. And again, VAB is therefore going to be R4, which is 4 ohm, times 0.38 amperes. Yeah, VAB second. So 4 times 0.38 amperes is just 1.52 volts. Now I can finally draw the equivalent circuit of Thevenin, which the problem was asking me to find. So the equivalent circuit of Thevenin will just be the following one. We will have this, a big fat plus and a big fat minus here, VTH is the equivalent voltage. And we will have a resistance, RTH, the equivalent resistance of Thevenin, and then this side A, and this side B, and we'll have plus, minus, and VAB here in between. So finally VTH, so the voltage, the equivalent voltage of Thevenin is gonna be given by V first AB plus V second AB. So VTH is just 3 where was it? What was it? 3.6? Yeah, 3.68 plus 1.52. So VTH is just 5.2 volts. So there we go. This is the equivalent circuit of Thevenin drawn at the point AB, just like the problem was asking us.